All right, welcome back. We're going to go through a quick rundown of your Unit 10 test review here. The answer key is posted online, which will look very similar to this document, so you can look at that, pull that up, and print it off if you need to. But just a quick rundown of what we're doing here on the Unit 10 test. So number one, they give you a center point and a point on the circle. You got to find the radius first. Then you can plug that in to your equation of a circle. Remember, it's x minus h squared y minus k, so you do the opposite signs. For number two, a whole bunch of completing the square here, and you're determining whether you have a parabola, circle, an ellipse, or a hyperbola. If your x squared and y squared terms have the same coefficient and are both positive, that's a hint that you have a circle. So again, you can look at the completing the square work here. I'm not going to go through every single detail there. If you only have one squared term, that's a hint that it's a parabola. So even if you can't do the completing a square, you should be able to identify correctly which one it is. The bottom two, you're going to have different coefficients on your x and y squared. And what you're looking at, if they're both positive, that's an ellipse. And if you have one positive, one negative, that's a hyperbola. So I'm going to slide this up just so you can see the work here. Again, factor out that lead coefficient, complete the square. You're going to put group your x's and y's. So this is what we've been doing through the whole chapter here. So again, you can see that, factor out the lead coefficient, complete your square. Don't forget to multiply when you head over to the other side. Final step to divide. So again, if both terms are positive and have the same coefficient, talking about the squared terms as a circle. If you only have one squared term as a parabola. If you have two squared terms with different coefficients, but they're both positive, that's an ellipse. Two squared terms, different coefficients, one is negative, that's a hyperbola. All right, graphing an ellipse. So we have x squared first here, and you can see that this is our a value here, and then we've got our y value, so x squared first. So we're going to go out 5 to either side and up 7, down 7. And you can find c, again, a squared minus b squared. And I got to backtrack here. This is the bigger one, so that one should come first when you see a graph like this. So that's why you have the y squared first. So this is elongated upright. So the longer one, that's always which way the ellipse is going to run. So if this one is bigger, then we're going this way. So technically we should put that first, since that's the larger one. All right, given the following equation, negative here, that tells you it's a hyperbola. So our center point here we can see is 4, negative 3. And from that you can get a and b. Once you have a and b, a squared plus b squared equals c squared. So c is the square root of 20. Once you have all of that material, you can find your vertices, foci, and eccentricity. Here we have a parabola. It's opening down. X squared, so we know it's up or down, but because this is negative, we know it's opening down. We know P is 5, so then we can get our focus. We get our vertex from here, so 5, 2. And then we can go down 5 units to get our focus. The directrix would be up 5 units from this, so y equals 7. Axis of symmetry goes right through the vertex, so that's x equals 5. Hyperbola, they gave you the graph, and they gave you this box here, and that's key. So our center point is right there at 2, negative 5. This is our value of a, which is 3. And b is 3, and that's okay. They can be the same. So a squared and b squared both happen to be 9 in this case. X minus 2, y plus 5. Number 7, they tell us we got a parabola. They tell us we got our focus at negative 2, 3, and the directrix is x equals 8. Parabola always opens away from the directrix and towards the focus. So the vertex here has to be halfway between those 2 points, which is 3, 3. And P is 5. From there, we can write our equation. If it opens left or right, y squared. Since it opens to the left, this has to be negative. You do not have to draw the rough sketch. I do think it helps, however. Okay, number 8, we got an ellipse. Again, it's a very rough sketch. They gave me the vertices, so you see the vertices here at 7, 5, at 7, 5, and 7, -1, and at 12, 2, and 2, 2. This way you can calculate A and B. Obviously, the center point is right in between there. It's 7, 2. So A is 5. We're elongated this way, so x squared comes first, x minus 7. And the y term is second, so y minus 2 squared. And you have A and B right from the distance from your center point to your vertices. All right, last page. Got a system of linear equations. You can do this by elimination. Using multiplication, you could solve one of them for x or y. I don't recommend that because then you're going to get fractions. So I used the fact that the y's, one was positive, one was negative. So multiply this one by 4, bottom one by 7. That'll get you here. Now these are opposites, so the x's will cancel out. Solve for x. Plug it back in. You put in either one. I chose the bottom one. Looked like less work. So x is -5, y is 13. Number 12. Last problem here, word problem. Outer door of an airplane hangar. So if you've ever seen an airplane hangar or a greenhouse, they kind of have that, half circle, semi-elliptical, parabolic shape. So it says it's in the shape of a parabola. The door is 120 feet across and 90 feet high. If you've ever been past an airplane hangar, they can be pretty big, obviously, when you're getting jumbo jets and private planes and that in and out. Find an equation describing the door shape. If you are 6 feet tall, how far from the edge must you be so you can walk in without hitting your head? So obviously, if we're in the middle, we got plenty of room, but if you're close to the edge, you don't want to get nipped there. So this is 120 feet across. I purposely made this 0, 0. And I made this, then if it's 90 feet high, 0, 90. So I have a vertex here, and I can use either one of these 2 points as an x and y coordinate on my parabola. So we know this is -4p. We don't have that value, but we have a vertex, and I can plug in the point. I use 60, 0, and that allows me to solve for p. So p was 10, so this is now -40. So here's my equation using a point on the parabola and the vertex. And this is x squared because opening down, and that's why this is negative. Once I have this equation, go ahead and plug 6 in for your height. So you're 6 feet tall. That's a y value here. And it says how far from the edge of the door must you stand. So we'll put the 6 in here. We solve for x. We get 57.97 feet, which means we can go, call it 58. 58 feet this way or 58 feet this way. So you need to be 2 feet from the edge, and you'll be able to walk into that airplane hangar without getting the knot on your head. All right, so that wraps up the test review. As always, got any questions, shoot me a Google Meet or Hangout request or an email, and I'll get back in touch with you. All right, thanks.